Kia ora 13MCA. This video is for Barnaby and it's a really nice question out of Old Delta 18.3 and it's question 14. So you've been doing lots of work in this exercise on questions like this where we've got z to the power of 7 is equal to, I don't know, negative 8i, right? And we've got good at using de Moivre's theorem for that. So we'd start that one off by going like this. R cis theta to the power of 7 is equal to, so thinking about negative 8i, that's down here. So it'll be 8 cis, and then we'd have negative pi on 2 plus 2n pi, right? Or in degrees, we'd have equals 8 cis negative 90 degrees plus 360 n degrees. And we work it through from there like this. Okay, so this question somehow feels different. And the most common mistake that you can make on this is to try and substitute polar form in to the z in there, and you'll find that you get a humongous mess. So I'll show you kind of how that goes. Barnaby, I suspect this is what you tried to do. So if you go like this, then it kind of looks promising, right? Because we get r to the power of 4 cis of 4 theta minus 24 r squared cis 2 theta plus 169 equals 0. And it looks like you can do some kind of double angle thing in there. And I'm sure you can, but there are two way easier ways to do this. The key is not to switch to polar too early here. Instead of doing anything with polar form, we're just going to treat this as if we were back in level 2 algebra. And we're looking at u squared minus 24u plus 169 equals 0, where u is equal to z squared. Now, you can probably guess that I'm going to do completing the square on that, or you could do quadratic formula. But I'm also going to work straight with z squareds in here. So I've got z squared minus 12, z squared minus 12, and now I need to take out the 144 and add 169. So that's level 2 algebra completing the square. That gives me z squared minus 12 is equal to negative 25. So z squared minus 12, squared. Z squared minus 12 squared is equal to 25i squared. Z squared minus 12 is equal to plus or minus 5i. So z squared is equal to 12 plus or minus 5i. There are two ways you can proceed from here. You can either solve, remember early this year or a couple of weeks ago, we did how to find the square roots of a number working in rectangular form, right? So we could now go a plus bi squared is equal to 12 plus 5i. A squared minus b squared plus 2abi is equal to 12 plus 5i, and we can work that through, right? So that's kind of a set piece, find the square root of a complex number, and we could do the same thing here. And from that we would get two nice rectangular form answers. But I want to show you how to do it in polar form, partly because that's what the book is working on in this exercise, but also because I think quite a few of you probably could do with more practice on the polar form rooty stuff. So looking at what we've got here, we've got z squared is equal to this. This number is in the first quadrant. So 12 plus 5i means I'm out here. You should be spotting straight away by now that you've got a 5, 12, 13 triangle by Pythagoras, like a 3, 4, 5. So that gives me r is going to be the square root of 13. What is theta? Well, theta is an easy one because we're in the first quadrant. So theta is equal to the angle whose tan is the y over the x, and that gives me 22.6 degrees. So we're now in a position where we can use the de Moivre's theorem stuff, and it's pretty straightforward from there. I'm going to do the same thing with this complex number here. So 12 minus 5i is the reflection down here. So again, r is equal to root 13, because that's 5 and that's 12. Whoops, that's not 12, that's 12, and so that's 13. Hang on, is that right? Let me just check if I've got this right. No, r is not root 13, r is just 13. I'm getting ahead of myself. Okay, sorry guys, look, I'm not going to rewind this. I'm just going to fix that up. So I went too fast there. It's a 5, 12, 13 triangle. Okay, so at this stage, we're working with z squared. The root 13 is going to come in when we do the de Moivre's theorem thing. So going more slowly, here's where we've got to. We've got r cis theta squared is equal to 13 cis of this one, 22.6 degrees, right, which is that arg there, plus any number of spin arounds of revolutions. So it's 22.6 degrees plus 360 n degrees. Okay, now expanding that, we get, by de Moivre's theorem, r squared cis 2 theta is equal to 13 cis 22.6 degrees plus 360 n degrees. I'll do this one in a minute. That gives me r squared is equal to 13, so r is equal to root 13. 2 theta is equal to 22.6 degrees plus 360 n degrees. So looking right back to the start, just checking what we've got. We've got a quartic, so we're going to have 4 solutions. 2 are going to come out of this one, and 2 are going to come out of this one. So the 2 solutions from this equation will be, so Z1 is equal to root 13. Now let's look at what theta is. Well, 2 theta is all of this. So theta is equal to 11.3 degrees plus 180 n degrees. So the first root will be root 13 cis 11.3 degrees. Now just think about where that is. So that's a tiny wee angle there. If I do 180 around, I end up down here. So we want to write that angle as Z2 is equal to root 13 cis 11.3 minus 180 degrees. So that one is root 13 cis of negative 168.7 degrees. So that's Z2. Okay, so there's Z1 and there's Z2. Now we're going to work through the second part. So Z squared is equal to 12 minus 5i. Please don't hang up the video. I know there'll be some of you who think that you've got this down, but we've got to make sure we get the second 2 roots. So Z squared is equal to 12 minus 5i, which is equal to 13 cis of negative 22.6 degrees plus 360 n degrees. And again, r cis theta squared is equal to this. So r squared is 13. 2 theta is equal to negative 22.6 degrees plus 360 n degrees. Theta is equal to negative 11.3 degrees plus 180 n degrees. So that's by de Moivre's theorem. And we do need to mention that. Okay, so now Z3 is equal to root 13, because r is equal to root 13, cis negative 11.3 degrees. So that's the angle there. And the second angle is this one round here. So Z4 is equal to root 13 cis of 100 and what did I come up with? 168.7 degrees. So there you go, Barnaby. Great question. Guys, please keep sending them in if you're hitting trouble. This old Delta book has got lots of good challenging problems. So there's not much point just sitting there and getting stuck and then kind of spending a quarter of an hour and not really getting underneath or into the question. So just flick me an email and I'm really happy to YouTube.